need to share this with anybody. So I am recording now, and we're doing lesson 2-3. And then a reminder, this is not on Wednesday's quiz. You will be quizzed and tested on this at some point, but not on Wednesday. So just a reminder in case you're going over stuff between now and then and you're like, wait a second, do I have to know this? The answer is no. Okay, so we're talking about something called biconditionals. Remember when we did bisections and we had a segment or a midpoint or a line or something that intersected an object into two equal pieces? Bi just means two as a root, and so a biconditional means that we're going to have two conditional statements. That's all biconditional means. It's essentially two conditional statements. It's a statement that contains the phrase if and only if. So it must have the words if and only if for it to be a biconditional. And it's a conjunction of a conditional and its converse. For those of you with your cameras up, if this is conditional, can you show me what converse is? What's my hand sign for converse? Good, I gotta scroll. I got one person helping me out. I know some of you are on your iPad, so I know that's why I won't see you. I have 2 people helping me out, 3 people, awesome. So converse looks like this. Again, if you're on your iPad, it's okay if you don't flip back and forth. But see that I'm doing this, which means that I switch my hypothesis and my conclusion. If my conditional is written as P arrow Q, then remember the converse is written as Q arrow P. That just reminds me that I switched them. Very good. And then also remember, we learned the word conjunction last week. That's your and. So if I have like P and Q, essentially we're doing the and with my conditional and my converse. Okay. So let's look at what a biconditional looks like. So I wrote you a biconditional statement here. It says, a student earns high grades if and only if he or she studies a lot. So my conditional is the exact order it's written. So I just take out the if and only if and put an if at the beginning and a then in the middle. I keep the student earns high grades at the beginning and I keep he or she studies a lot at the end. So you can think of your hypothesis here being a student earns high grades. That's the first part of my conditional statement. And then he, she studies a lot. That's your conclusion. So I'm going to write this as a conditional now. I'm going to say, if a student earns high grades, then he/she studies a lot. And then that still matches. My conclusion is still at the end, and my hypothesis is still at the beginning. And then as those of you showed me with your hands, I'm going to switch them now. And so I'm going to write, if he or she studies a lot, then the student earns high grades. You can put student at the beginning of the sentence if that makes sense, like English-wise in your mind. It does not matter to me, but like the meat of the sentence, like earning high grades should now be at the end and studying a lot should be at the beginning of the sentence. So if he/she studies a lot, then the student earns high grades. I'm going to keep highlighting just to stay consistent. You don't have to highlight, especially if you've gotten this conclusion and hypothesis under control. Don't feel like you have to highlight, but for those of us who still need a reminder, this is just us switching. Okay. Any questions on rewriting a biconditional as a conditional and as its converse? You doing okay so far? Okay. Now, a biconditional statement can be true or it can be false. In order for it to be true, remember I told you it's an and. In order for an and to be true, we need both P and Q. I need both the statements to be true. So in order for a biconditional to be true, both the normal conditional and its converse must be true. Now, remember last week we talked about like the validity of statements, and I told you that there was like truth equivalence between like the conditional, converse, inverse, and contrapositive. Does anyone remember which one is like the same truth value as the conditional? Was it the converse? Was it the inverse? Was it the contrapositive?
The contrapositive.
Contrapositive, very good, Michael. And I remember con and conditional and contrapositive. So those, I know I'm writing super messy off to the side, but it's because I want you to still see my other notes. The conditional and the contrapositive are the same truth value. So if the conditional is true, the contrapositive is also true. Then the other two, both of the verses, that's how I remember in my head, the verses, the converse and the inverse, those are the same truth validity. So the converse and the inverse are both the same. And that's helpful because like once you start putting knots and start moving things around, sometimes it can be confusing to know whether it's a true or false statement. So if I know like the conditional is true, then that means that the contrapositive is true. And then vice versa. If I know like the inverse is true, then that means like the converse is true. Well, what a biconditional is saying is that both the conditional and the converse are true. So if the conditional is true, then also the contrapositive is true. And if the converse is true, then the inverse is true. So if I have a biconditional statement that's true, all four of my conditional statements are all true. Everything's true all the time. And that's like only a special thing. I don't know if you can hear beeping. There's like a truck outside my house. That's really strange. I have no idea where I was going with that sentence, but everything has to be true. And sometimes that's a hard thing to find. So we're going to do a real life example of deciding whether things are true and false. And then we're going to talk about a couple other specifics about biconditionals, and then we'll do a couple last examples. So this next one, we're doing the validity again. So we're going to decide whether this statement right here is true or false. And so in order to decide that, I have to see what its conditional is, decide if that's true or false, see what the converse is, decide whether that's true and false. This says, a student is caught skipping class at Cathedral if and only if he or she earns 2 detentions. If it's conditional, you just keep it in the same order that it's in. I would go, if a student was caught skipping class at Cathedral, then he or she earns 2 detentions. So as I write that conditional, you think about whether that's true or false. As we write this, you decide whether it's true or false. If a student is caught skipping class at Cathedral. And when we have these, you'll feel like the last couple homeworks and then the homework on this lesson, it feels like a ton of writing. If you feel like you're writing too much, don't be afraid to abbreviate things just to make sure, especially if it's like a test or quiz, that like I understand what you're abbreviating it to. You can't just like make like some random word an abbreviation like CHS, like we all know that that means Cathedral High School. You can't like abbreviate skipping into like SK and call it a day. So as long as I know what you're talking about, you're free to abbreviate it, but make sure that like it's self-explanatory enough. Then he/she earns 2 detentions. And so I can write 2 as a letter instead, or as a number, excuse me, detentions. If I keep with my highlighting trend I'm doing, hypothesis is a student skips class at Cathedral. And my conclusion would be he or she earns 2 detentions. Now, give me a thumbs up or a thumbs down. Is that true or false? If you don't know, give me a thumbs in the middle. So thumbs up is true, thumbs down is false, thumbs in the middle is like, I really don't know if that's a rule or not. Okay. I've got a couple thumbs. Again, I know some of you I'm not going to see. A couple thumbs in the middle. That you probably just haven't heard this rule. I don't know if it was emphasized last year and this year we're like really not doing detentions, but the answer is true. Thumbs up. If you got caught skipping class, you would get 2 detentions at school. So just believe me, if you didn't know that was a rule, we're going to say that that's true. Okay, now I have to do the converse. Can someone tell me what the converse would be?
If he or she earns 2 detentions, then a student is caught skipping class at Cathedral.
Very good. Thank you, Ella. If he or she earns 2 detentions, then a student is caught skipping class at Cathedral. So as I write that, you decide or start thinking about whether you think that's true or false. If a student earns 2 detention, then he/she is caught skipping class at Cathedral. I'm going to highlight again. I'm just here for consistency. That earning detentions is my conclusion, and my skipping class is my hypothesis. What do we think about that? Do we think that's true or false? If you earn 2 detentions, then you were caught skipping class. If you think it's false, then I would want you to think of an example of when you might earn a detention or 2 for not skipping class. So if you can think of an example where you could earn 2 detentions for not skipping class, then that would be a false sentence. So what are we thinking? True, false, true, false. Good. I see a false. That's true. That's a false statement. Can anybody give me an example of why you might earn a detention that's not skipping class?
Not wearing your lanyard.
Lanyard, yep, that's the best example. Any other examples? Uniform infractions are a big one. If you're like late or tardy to class without a pass, you can get a detention. If you're just like not doing what you're supposed to be doing, there's like a lot of like little reasons, but like I can list them all for you. So those are all examples. Like you could forget your lanyard twice and then that would give you 2 detentions. You weren't skipping class, you just forgot your lanyard. And so that's a false statement. Now, because my conditional is true and the converse is false, my biconditional is false. Both of them need to be true in order for it to be a true statement. And since we came up with counterexamples for the converse is false, which makes the entire biconditional false. Everyone good with that? Okay. Next, definitions are always true biconditional. So once we did that example, you're probably like, oh, well, I'm sure I can think of a ton of counterexamples for anything that we write. Well, yes, but often if you have a definition, those are always true biconditionals. If it's a situation like what we just went over, there's a lot more room for error. But like, let's look at this first example I gave you. I said if an angle is a right angle, if and only if its measures is 90 degrees. Okay, if I said the conditional, if an angle is a right angle, then its measure is 90 degrees. That seems right. We can't complain. A right angle by definition is 90 degrees. Flip it. If a measure is 90 degrees, then an angle is right. Well, that's also true. That's a definition. So definitions are true whatever way that we put them in. And I can tell that these are biconditional statements because they say if and only if. If right angles, if an angle is right, if and only if its measure is 90 degrees. And 2 angles are supplementary if and only if their sum is 180. And a statement is biconditional if and only if it contains the phrase if and only if. I do recognize that this one says if and only it. It should say if and only if. That's my fault. Also, something I probably should have mentioned earlier, like I said, there's a lot of writing, so you may want to abbreviate. A really easy way to abbreviate if and only if is to write IFF. If you want to write, or if you've ever seen IFF, like if with a lot of F's, it feels like, That's the same thing as if and only if. So as we write more of these, you may be tempted to write if and only if as IFF, so you don't have to spend more time writing little insignificant letters. So that's just an abbreviation. All right, we got 2 examples. It says, given the following true statement, write its converse. If the converse is true, combine it with the original statement to form a true biconditional. If it is false, then state a counterexample. So we're going to do the first one together, and then I'll have you try the second one on your own. This one says, if 2 angles are vertical, then they are not adjacent. They already told me that that's true, but I also know that that's true because vertical angles, by definition, are not adjacent. So we're going to write the converse. Can someone help me with the converse? You guys have gotten really good at it. Who wants to help me?
If they are not adjacent, then 2 angles are vertical.
Very good. Thank you again, Ella. If they are not adjacent, 2 angles are vertical. So that's my converse. They are not adjacent. And see that this statement has not in it. That doesn't make it an inverse or negating or anything. Not as was in the original statement. So I don't have to like do anything crazy with the not. I'm just copying exactly what I see. If they are not adjacent, then 2 angles are vertical angles. Now, is that true or false? If they are not adjacent, then 2 angles are vertical. What I'm thinking in my head, okay, if they're not adjacent, can I draw 2 angles that aren't vertical either? Can I draw non-adjacent and non-vertical angles? What are we thinking? Do you think this is true or false? Anybody?
I think it's false.
You think it's false? Thanks, Kamara. Could you help me draw an example, or do you just know it's false?
Well, I thought of it as like, let me go look. So if there's a non-adjacent angle, it would be like, let's say an obtuse angle.
Okay.
Isn't that, yeah. So, and then, well, I don't really know now that I think about it. Maybe.
You're right that it's false. I'm going to confirm that it's false. There's a couple different ways I could draw it. Does anybody else want to take a stab at what I could draw?
Like when we first learned about them, there was one that was like a giant one, and then one that came off of it, but they didn't share the same vertex.
Good, like this?
Yeah.
Good, those are not adjacent, and they're also not vertical. Good, that's an ugly one. That's a great example. Another one that we see a lot is if I have like a straight line, and then I have 3 angles coming off of it. So I've got like that one, and then like another one over here. These 2 are not adjacent, but are they vertical? Those are not vertical. So those are not adjacent and not vertical, as well as the one that Ella had me draw a second ago too. There's a ton of examples that we can think of. And if you knew that it was false, that's the first step. That's awesome. But then the second step we need to do is see if we can find a counterexample. I know it says state a counterexample, but this picture is just as good as a statement. So I can draw any one of these, or I could draw like another example we like to do is like the 2 lines and like a right angle in there. And like this angle and like this one are not adjacent, and they're also not vertical. So that's like another thing that you could draw too. So there's several different pictures that we've seen that I've tried to trick you with to see if they're adjacent or vertical, and this is neither or. Okay, you look at the next one and you try and decide what's going to happen. Decide what the converse is, decide if it's true or false, and then if it's true, write a biconditional. If it's false, write a counterexample. I'm going to join you in 1 second, okay? So you see what you can do first. I know writing takes a while, but I'm going to join you. Remember, converse is switched. So I'm going to say, if it is divisible by 2, ooh, I don't know what happened there, then the number is even. And then do we think that's true or false? If it's divisible by 2, then a number is even. Can any of you think of a number that's divisible by 2 but is odd? I can't. Can you? None of the odd numbers are divisible by 2. So this is a true statement. So I have a true statement and I have a true statement. So now I'm going to write a biconditional. When I write that biconditional, I'm going back to the beginning, and the only thing I'm doing is I'm taking out if, and I'm taking out then, and I'm putting if and only if in the middle. Everything else should be in the same order. If a number is even should go first, it is divisible by 2 goes second, and just in the middle is your if and only if. So as I write it down here, I am going to label it biconditional in case I come back to look at my notes later and I'm like, what is this last sentence? Why did I find this? It's a biconditional. So I'm going to say a number is even if and only if it is divisible by 2. And then don't forget, you can write if and only if as IFF, and that is also correct. All right, any questions on what we've done today? Okay, I'm going to pull up the answer key to the quiz. Are there any questions or anything we need to go over on that today? I will have time to review before we take the quiz, so don't feel like you have to have all your questions ready to go now. But I do want you to feel like you can ask anything if you want to ask anything.
I have a question.
Yeah.
So whenever we say, so for instance, like the last problem we just did, the if and only if, so we don't look at it as like, that's the only way it could be even, right? We just look at it like as because when I thought of it as like a number is even if and only if it's divisible by 2. Like, I don't know how, but it's like, I don't know how to explain my question. So
yeah, go
like,
ahead.
If and only if is just, I mean, that statement is true, but a number can be even if, is divisible by, I don't know how to explain the question.
So a number can be even and be divisible by other things, right?
Yeah.
But at base level, every single even number is divisible by 2. So even if they're also divisible by 4 or also divisible by 10 or also divisible by 5, all of them at least are divisible by 2. And so that's kind of why that if and only if works there.
Okay.
Does that make sense? It doesn't have to be an end all be all. It's not like it's only divisible by 2 and that's it, because we know there's a ton of even numbers and like they have other factors than just 2. It's not only 2's make up these even numbers. It's like 2 and 5 and 2's and 3's and 2's and 7's, but it also is divisible by 2, and that's only even numbers. No odd numbers are divisible by 2. Yeah, and as we do more of these, we have to think about things a little bit differently and a little bit weird, and so we'll kind of work through those as we do them. So that's a good way to kind of like get our brain thinking a little differently. Anybody else questions on the notes or on the study guide?
I have a question on the study guide. What vocab is there going to be that we need to know?
Good. So vocab we've learned conditional, converse, contrapositive, and inverse. So all of those things. I'm not going to give you like a definition, like this is what the converse is, but like if I say like write the converse or write the inverse, you need to know like inverse is switched, right? And you need to know like contrapositive is like switched and negated. Negation is probably a good word to know. Like it means that you have negative or not. I don't know if I told your class, but I've told other people, you need to know the word inductive. That's the only reasoning we've done. And remember, inductive reasoning is patterns and observations. So if I ask that, your answer is inductive. The only other thing I think is like conjectures. And remember, conjecture is just like an educated guess. We haven't done a ton of vocab words in this unit. We did more of those like different statements and a little bit more like writing and not as much vocab this unit. Does that help, Kate?
Yeah, that does. Thank you.
You're welcome. Anybody else questions for the good of the group? Okay, I'm gonna stop sharing, and if you are good on your questions, you're free to go. I'll stick around. I also have like a flex Zoom that I'm gonna get on in a couple minutes too. So if you have any other questions, you can find me there, or you can just stay after this and I can answer a couple questions. I'll see you in class on Wednesday. So have a good rest of today. Have a good Tuesday.
Thank you.
Thank you.
Thank you.
Bye, you guys. Oh, bye, Colin.